Hello everyone and welcome to 7th grade Honors Math Extension. In this video we're looking at square and cube roots. Our learning target is to make sure we can solve simple equations to find the square or cube root of a number at mastery as measured by our proficiency scale. This will help us to succeed and master standard 8EEA2. Use square root and cube root symbols to represent solutions to equations in the form x squared equals p and x cubed equals p, where p is a positive rational number. Evaluate square roots of small perfect squares and cube roots of small perfect cubes. Know that square root of 2 is irrational. So before we dive into our perfect square and cube roots, it would be important to make sure we understand our real number system. You guys have been working with natural numbers or our counting numbers like 1, 2, 3, and so on since the very beginning of school. Whole numbers are all of those counting or natural numbers and the number 0. Integers put in the negative versions of our natural numbers. And then rational numbers include any terminating or repeating decimals, fractions, and even percents. Most of the numbers you've worked with in your life are rational, and the ones that we're looking at today with our square and cube roots will solve to make more rational numbers. Now, the other thing we need to keep in mind with this are our math operations, because finding roots is actually just another math operation. So we know that addition and subtraction are inverse operations, and repeated addition is just multiplication, which is the inverse of division. And then repeated multiplication, as we saw, is what we do with our exponents and our powers. Now, we usually don't use a symbol to represent exponents, but sometimes you might see that caret symbol on the calculator to show that you're putting in an exponent. And then the inverse of taking a number to a power is finding the root of that number. Often we call the symbol that we use there the radical, and we can also call finding the root the radical. So to explore our square and cube roots, let's start by looking at some squares and their roots. So in A here we have 9 squared, so 9 times 9 is going to get us 81. If we tried to do the inverse and find the square root of 81, all we need to know is what number times itself makes 81. We can use what we know about our math facts to find out that 9 times itself equals 81. With 11 squared, 11 times itself equals 121. So if we go in reverse to find the inverse of that by doing the square root of 121, the number that multiplies by itself to make 121 is 11. I do have some of our perfect squares from 1 to 16 squared, or from the square root of 1 to the square root of 256 listed. You can use lists of perfect squares as a reference, just as you could use a multiplication chart to see what numbers times themselves equal the number we are finding the square root of. So if we see an equation such as the square root of 100 equals x, and we're trying to figure out what x equals, we could just solve that out normally, 100 finding that square root, and we can use our perfect square list to check, but we would see that 10 times itself is 100. So the square root of 100 is 10. For the square root of 49, what number times itself equals 49? 7 times 7 will get us 49. So the square root of 49 is 7. Sometimes we might see our equations written as a variable squared equals a number. When this happens, to solve for our variable, we would need to do the inverse operations to isolate our variable, just as we would if we saw addition, subtraction, multiplication, or division. So since we see the square, we can undo the square with the square root by finding the square root of 25. So the square root of 25 is 5, meaning that 5 squared equals 25. Now, solving for cube roots is very similar to solving for square roots. Just as a number squared is a number times itself, a number cubed would be a number in a multiplication problem 3 times. So a number times itself and then times itself again. So to find our cube root, you need to figure out then what number times itself again, or cubed, would get us the number we are trying to find the cube root of. Now with cube roots, you're mostly going to be working with our perfect cubes, which are numbers that are going to solve into our whole numbers. So you can use the perfect cubes listed below as a resource as you work through these problems. You may see a problem for a cube root listed as something like x cubed equals 343. And this means the same thing as the cube root of 343. You notice that the cube root symbol has that radical, but instead of having no number inside of it, this now has a 3 inside of it to show that you are doing the inverse of putting a number to the third power. So we can check on our perfect cube list, and we see that the number cubed that will get us 343 is 7. So the cube root of 343 is 7, meaning that if x to the third power is 343, then x must be 7. Let's get a little more practice with some slightly different style problems. Now, these problems all have fractions and decimals in the radical that we are going to solve for their square or cube roots. Now, don't worry, we can use our perfect squares and perfect cubes to solve all of these using what we know about the multiplication of fractions and decimals. So for the square root of 1/9, we know that 1, we can find the square root of that and get 1, and the square root of 9 would get us 3. So while finding the square root of 1/9, we need to figure out what number times itself would equal that. Well, since when we multiply fractions, we multiply together the numerators and denominators, we can just use the square root of our numerator, in this case 1, and the square root of our denominator, in this case 3, to find the fraction answer for our square root. We can do the same thing with decimals. What number times itself would equal something to the value of 25? Well, 5 times itself is 25. Since this decimal is 25 hundredths, we need to know what decimal multiplied by itself would equal 25 hundredths. And if I do 5/10 times itself, I would get 25 hundredths. For the square root of 1/36, again, we can just find the square root of our numerator and denominator separately, because 1/6 times itself equals 1/36. So that is the square root of 1/36. We can use all these same skills with cube roots as well. So for the cube root of 8 thousandths, we would look and see what the cube root of 8 is. Checking our perfect cubes here, it looks like 2 to the third power gets us 8. So then what decimal with a 2 in it could we multiply by itself, and then by itself again, to get 8 hundredths? Well, that would be 2/10. For the cube root of 1/125, we need to figure out what 3 fractions could be multiplied together to make that. They have to all be the same. So we can find our cube root of the numerator and denominator separately, because we just multiply those numerators and denominators together. So 1/5 to the third power. So 1/5 times 1/5 times 1/5 equals 1/125. So that is our cube root there. 1 is one of my favorite squares and cubes to work with, because 1 times itself is just 1. So in this case, we have our 1,000th, so that would be 1/10 to the third power to get that. So the cube root of 1,000th is 1/10. One of the greatest real-world applications we see for square and cube roots is within geometry. And in fact, we use those square units in area. So here we have Alana who drew a diagram of a local park, which is in a square shape. And we're going to find the length of each side of the park. And they gave us the area of 49 hundredths square miles. We can use our area formula for a square, which is just side squared. And we can plug in the information we know. In this case, that our area is 49 hundredths. To isolate our variable, we're going to do the inverse of squaring, which is finding our square root. And then, since this is a fraction, I can use my perfect squares for my numerator and denominator to find my fraction answer. So the square root of 49 is 7, and the square root of 100 is 10. So the side lengths of this square would be 7/10 miles. For cubes, we often see those in volume in geometry. So here, Crate Company builds wooden boxes of all sizes. The drawing below shows the volume of one of its cube-shaped boxes. We are finding the edge length S of the box. And they've given us our volume of the box, 125 cubic inches. Since the volume formula for a cube is just side cubed, we can plug in what we know, which is that the volume is 125. And to isolate our variable, we will need to do the inverse of going to the third power, which is finding our cube root. And then we can go back and we can check our perfect cubes, or we can do some mental math to figure out what number to the third power would get us 125, and that is just 5. What does this video make you wonder about square and cube roots? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learn from your failures, then you succeeded.